Так, всем привет. Рада вас всех видеть. Спасибо, что пришли на наш доклад.
Hello, thank you for joining us at our presentation. I have a poll for you. A show of hands who have worked with Kubernetes. Great, cool. How about network policy? Who have worked with network policy? Less hands, but hopefully you would want to use both Kubernetes and network policy. It doesn't even matter if you have ever used Kubernetes. My name is Dmitry Yevdokimov. I am CTO and establisher of Lumtree startup, and we do everything in security. And you probably know me on KS and Security Telegram channel, where I publish interesting news related to Kubernetes. And I also have been to various conferences. Hi there. I'm Sergey Kanibor. I study the IB part, the information security part of Kubernetes, and I also participate in developing the product. So this is what we are going to do today. We can keep going on and on about Kubernetes, and our main idea is to eliminate every conceivable gap you might have in a network policy of Kubernetes. So your teams would never tell you that you can't do it this way, we don't know how. Let us start with the very beginning. Probably not all of you know how it all works in Kubernetes. Kubernetes has a very flat network. All pods have IP addresses, and by default, communication goes through DNS service discovery. So they address each other by names, and IPs themselves do not really mean a thing in Kubernetes. Your service starts, then it goes from one node to another one, and this IP went to a different microservice. So at one point of time, this IP belongs to one service. In next second, it goes to a different service. So IP address is not something that you wish to follow in Kubernetes in terms of threat hunting, in terms of researching incidents, because it pretty much goes from one service to other. If your load increases, the number of services increases, and vice versa. And so it is great. It makes your resource usage more effective. And every pod, by default, can communicate with any other pod, which means that by default, irrespective of whether or not you're using one namespace or different namespaces, every pod can communicate with every other pod. So if an adversary compromises a particular pod and gets into this container, he can scan the whole network and get access to the whole network. In certain cases, in one cluster, you may have several dev test stage prod, and in your prod in production, you have card data, user data, and all that. And then all of a sudden, developers don't have access to it, but they do have to scale namespace, and then he addresses prod database and gets all the user data because there are no constraints in place. So when Kubernetes comes out of the box, the network is fully flat and everybody talks to everybody. Another important thing is that Kubernetes network is not provided by default. It's provided by a special interface called container networking interface. And then you need to pick out of plugin that CNI interface is going to make use of. Cilium and Calico are the most popular ones. There are some others, Kubernetes, etc., that CNI can use. And this is because Kubernetes is not an out-of-the-box kind of solution, it's a framework. And in our practice, we haven't seen any, every Kubernetes are unique, we haven't seen any totally identical Kubernetes. So you can encounter almost anything. So you pick one particular CNI plugin for the network to work. Each of them have their own peculiar issues. If you use something out of this, it may introduce certain peculiarities, so bear this in mind. So what's under the hood, so to speak? Either they work through IP tables or through a more advanced technology, eBPF, which is external Berkeley packet filter. So external Berkeley packet filter is different from the older version. Why eBPF is winning things over? Well, that's because this long chain is out that introduces latency and it decreases performance and hinders efficiency of execution. But eBPF comes with certain peculiarities, and you want to understand what your plugin works best with, the tables or eBPF. On to security. All of us are working towards zero trust concept. Anything could be compromised in your infrastructure. The attacker may try to develop his attack, and we want to make his life more difficult, and yet not to create hindrance to the developers developing new features. Not to jeopardize, not to hinder, not to become a stumbling block for the business. So zero trust is a way to go for us. To give you an example, somebody compromised a microservice. This may happen, and if we have certain constraints, the attacker cannot go beyond the so-called whitelist. If service A talks to service B and he gets to service A, he wouldn't talk to anyone but service B. Full stop. So how is it achieved in Kubernetes? This is the classification that we came up with. You can do it on application level, on service mesh level, Istio or Linkered, or the network plugins for CNIs that I demonstrated earlier. In application level, it is realized through commercial applications, more often than not, and through adding your own logic into your code. This may this may be injected later on. And it introduces additional financial load and additional uncertainty. And I'm going to give you an example later. On service mesh level, you have Istio and Linkerd with the help of sidecar container. So this is the instance that can cipher your whole traffic. Your application is agnostic to this logic, and this logic is only being handled by the proxy. So these service meshes allow you to do that. You can specify it all the way to the IP. It is also realized on user space level. And case 3 on CNI level. And you obviously cannot avoid using this level. You really have to use CNI. So it's realized by network policy, a specialized service. More often than not, it works on levels 3 and 4. You can control the IP address and the ports, and more advanced variants, custom variants, allow you to go as deep as L7, level 7. And importantly, they are realized on kernel space level. That is, when attacker gets inside the microservice, it works not in a way it works in one level below. So you have to have container escape, and only then on the node level he can be able to manipulate. But he cannot bypass network policy out of container. Istio can be bypassed provided the attacker is inside container. You can somehow mute sidecar container, and we can bypass this constraint in this way. And we are going to discuss network policy now. Network policy can be realized natively and also custom-made. So CNI makers can extend on them, advance them, improve on them, and we're going to see it. Network policies are not realized by Kubernetes. This is the task for CNI. There is a CNI funnel that is not capable of working with network policies. You just create this resource and he doesn't do anything about it. And this network policy just doesn't know how to limit anything, while the rest of CNIs can do it. Pay special attention to Cilium and Calico. They can support API group and custom group, Cilium.ie and Kerde project calico.org. They have their own custom variants. But let us begin with native network policy. Like everything in Kubernetes, network policy is YAML engineers that gets 500,000 per nanosecond. So the beauty of it is that you can approach security as a policy as code. You can store it in Git. You can look at the progress and modification of your policies. This resource is something that you get starting with version 1.7. Now the latest version is 1.24. If you make use of Kubernetes, it is bound to have network policy. So network policy, the way it works is using whitelist. The service can only work with what is whitelisted. So namespace is initially closed, neither ingress or egress traffic can go in or out. But then you say that front end can talk to backend and backend can address database, but you clearly, explicitly define who can talk to whom. It only the native network policy only works for code. Other instances like legacy infrastructure, virtual machines that are outside the Kuba, databases, they don't understand it. It can only be used, and the granularity level and the policy describes what it can address. And then N containers can be used. In one company, they have 56 containers working at a time. So basically, he doesn't know anything about it. And if any of the processes abides by the rules, then it's okay. If it is done by shell, then it's okay. It doesn't really understand and tie it to what's going on inside the container. That's what I'm saying. And this is an example for network policy IP version. You have a namespace where this network policy is being used. Then you have pod selector. So this way we're saying that this policy is to be used to microservices with label called role, and it's equal DB database. So we want to apply this network policy to database. There are ingress and egress, inbound and outbound traffic policies, and then blocks describing what we want to do with it. And not necessarily, I mean, this is us giving the general understanding. The egress traffic can come from a particular IP or IPs or particular namespaces where label project equals this and that. Or say a particular microservice should be tied to a particular front end. Policies are tied to pods or microservice using labels. You need to use labels in the right way so that microservice label this interacts with microservice label that. Here we have the ports named as well. So egress goes to particular IP blocks and particular ports. That's it. That's what native network policy is capable of. Obviously, network policy keeps developing. Kubernetes community releases new versions and tries to make it better. And here on this slide, you can see what has already been made, what are the changes that they've introduced, and what is in their plan. There is a work group. It's called Network and Policy API SHE Network Group. They work specifically to develop network policy network policy service in Kubernetes. The fact that they can support the fully qualified domain names is the new thing, and policies for the whole cluster. Right now, native policies are only used pertaining to a particular namespace. If you want one rule that would act for all microservices and all namespaces, you have to copy-paste it. But you want to have it irrespective of namespace, don't you? You want this microservice at this particular label to go to this, and that. And cluster-wide policy applied to any kind of microservices irrespective of namespaces would be a good way for it. The constraints are known, so Sergey is going to tell you what they're doing about it. Yes, I'm going to tell you about overcoming the constraints of native policies. Indeed, the industry keeps developing, and external CNI vendors with their custom policies are there to resolve this issue. And today we're going to look at two custom network policy, Calico and Cilium, because these are most frequent and most popular ones. And all slides are going to contain their logos on the slides. As you already know, by default, native policy can only be applied to pods. In custom network policies, however, it's extended. You can also use it to host interfaces, virtual machines, and other instances. These ones and that ones.
Calico имеет расширенный функционал в плане селекторов.
Calico has extended information in terms of selectors, much labels and much expressions. Calico went further. They introduced their own system that's first off, on the one hand, it kind of constrains, but then extends the functional, and you really need to bear this in mind when you make use of Calico custom network policies. Dmitry already mentioned that by default, native policies describe only what is explicitly allowed, whitelist principle. In custom policies, we can act differently. In Calico, there is this point action. We can not just use allow, but also use deny. We also can use a log and also pass. That would pass the existing rule and go on to the next one. In Cilium, they have similar approaches. And we're going to look at certain constraints as well later on. In the custom network policies, they have everything that native network policies have. We can use namespace selector and port labels, but in Calico we can also additionally use service account selectors, which is useful if you want to write a policy tied to pods that share a particular service account. And in order to do that, we can tied to that label. There is also support of CA policies, so you can describe it explicitly in policy and make use of it. And also extended protocol use and IP use is something that I'd like to mention. Cilium is very similar. They also are label-based, and we can name labels of the pods servers-based, especially when you say needs where endpoint is not behind the pod but behind the service in Kubernetes, and you can use this service label, and service label is very usable. In Cilium, you also have a predefined list like kube API, working nodes, and other kube APIs. Working nodes, and you can just use it in your policy. And another peculiar feature of Cilium is that you can have DN policies, which is non-existent in the native network realization. If you have several DNS names, you can just point to a particular DNS name and turn the policy the way we want it. In custom, you also have network set, and why would you want to use it? Say a part of your infrastructure is beyond Kubernetes, like virtual machines, etc. So you can limit their interaction with Kubernetes. We can identify the networks, whitelisted and label it, and then in policy in Calico refer to that label, and it would interconnect, and they could be used in policies. In Cilium, this can also be done. It can be stated explicitly in their policy. One peculiar feature of custom realization, unlike native realization, is cluster-wide policy. In native, you can only orchestrate pod-to-pod communication. Here, in cluster-wide policies, we can just name one label, and the policy would match in all namespaces. That is to say, we can address it to whichever pods just by naming it in the policy inside a cluster. Also, cluster-wide policy can be used for a host. By default, network policy, the native network policy, can only limit pods across the network, but we also can limit the host, that is to say, the nodes where they operate on. In Calico, you just need another resource and make use of it. In the lower left corner, you can screenshot of all kinds of ports that can be used for that for that purpose, and you can put it directly into your policy, and that way limit your traffic. But only levels 3 and 4 are supported there. L7, level 7 policies is there in custom network policy, unlike native network policy. But Calico is a little bit constrained. Only ingress routes are supported, only the incoming traffic. All policies have to have allow action. We cannot say that we deny something, prohibit something. And this is beta stage at this point. So this is Calico. In Silico, they also have support of L7 policies. But importantly, if we break a policy, if we try to break a policy, nobody knows. If L7 policy is abridged, nothing happens to packages. And in our host policies, importantly, L7 is not supported if node selector is used, if we address a particular node there. Dmitry touched upon network activity as limited with the help of service mesh. Calico and Cilium allow for integration with service mesh, and you can use it. If in your service mesh you decided to have less TLS communication, we can use it for L7 policies so that they understand what the heck is going on there. In Cilium, they have their own embedded service mesh. It works there, and it's there to substitute for the other service meshes. Alerts when policy works. Say you wrote a policy, and an adversary gets into a container, and we don't get to know whether he tried to use his attack vector, and by default this information is not given to us and we don't get this information. In Cilium, however, you can learn it. They have Cilium monitor embedded. You can look at the dropped packets and debug information and breached policies. And also they have Hubble with UI interface that allows us to look at which packets were drops or mixed. But not just the ones that's related to policy breach, but also the ones that is related to instability in network will create similar alerts. So it would be difficult to differentiate and to understand why exactly you have this alert. In Calico, though you can have action as log, it doesn't give you any information about breach in policy. It just writes information in syslog, and that's it. So this is a comparative table for your convenience, and I'd like to point out that custom policies do extend functionality unlike the native network policies, but at the same time they create additional constraints, so you need to be extra attentive not to make a mistake. Next I'm going to talk about tips and tricks when using network policy. By default, you can go with ingress rules and egress rules, inbound, outbound. If you don't do it explicitly, then by default it would be ingress. Same goes to Calico. In Cilium, if you don't if you are not explicit about it, the policy wouldn't just work. One other thing. Yes, policies are used as whitelist, but it can be written in such a way as to deny something. Here you can see default policies that would deny outbound and inbound traffic. So the policy in between is the one that you should use to create network policy. By default, if, say, you have several policies on top of a microservice, then Kubernetes will use allow policy. In Calico, you can manage priorities. They have order filled. The smaller the value, the earlier the policy is used, irrespective of whether it's prohibitive or allowing policy. It's going to go with this number, order number. In Kuber, DNS is important. So if you prohibit everything, you also need to allow for DNS traffic from each pod to kube system so that it works, still works. You can use cluster-wide policies that would be applicable to all pods and would allow all pods to go using port 53 to the kube system. Oftentimes, what you have a microservice that talks to Kube API, and it introduces certain difficulties. You may have a managed Kubernetes, and a Kube API can be somewhere else, and it's rather difficult to write a workable policy. So in a native network policy, you need to know for fact where your Kube API is, and you should write egress rules according to where it is, its address and port. In custom network policies, in Calico in particular, we can just name a service, and Calico would know that it's Kube API, and you can talk to it. In Cilium, there is a separate instance, Kube API instance, and we just name it explicitly, and it works. In our team, we have an insider joke how you know that network policy is not used in a company. If you have namespace on labels, then it means, I mean, if you want to control namespace to namespace interaction, you can parse it with a particular command and label them one at a time. With version of Kubernetes 1.21, the label is done automatically, and we can just name the label in writing our policy, and it would work for all the pods in this namespace, in the namespace, in a given namespace. Even if you did employ a policy, it doesn't automatically mean that it works. How do you know? Well, here in this slide, what you have in blue, it's a pod in the center. In magenta, it's a custom policy, and then a native organization that is not connected to the pod. It's in namespace, but it is not really implemented. You really have to know your labels. Even if you make a mistake in labels, the policy is not going to be used, and it's not going to create any effect. CNI vendors that give us an opportunity to make use of custom network policies allow us to mix and match native and custom policies, which is very good and non-constraining. If you want to use a Calico in one space and Cilium in another space, and you have native network policy, you can do it. And you can use it at one at the same time. Additionally, there are some other things. You can use policy engine, but then you need to specify which resources network policy is applicable to and which not. But it's a whole different topic. Specifically, you can use policy engine. So in Kubernetes, all the pods by default work in their own isolated network. But we can do it in such a way that they work and interact with all of the host interfaces. So in the manifest, you should put host network true value, and thus it will work in your host network, and it would bypass the network policy. Network policies won't impact it because they because of the way it works. Another interesting thing, but let me provide you with a caveat that it only works for overlay networks, and if the necessary capability is there in Cilium, in the documents for version 0.8, it was said that if the pod-to-pod traffic is controlled with Cilium, then when packages are sent over, the labels may hold sensitive information like Cilium identities. When knowing Cilium identities, we can actually manage pod-to-pod communication. Coordinates, ITCD, all that. So if you have this, we can substitute these values. I mean, it doesn't happen at all times, but it could happen potentially. And Cilium gives us a prompt how to mitigate it. You either cipher the whole traffic or use protected network. That's what they say about it. That would be it. Thank you. Thank you, Sergey. And we're almost there. So what are our conclusions? Initially, I forgot to point out where this presentation comes from. Oftentimes, people approach us and say, could you give us a firewall that understands Kubernetes? There are no hardware and firewalls specific for Kubernetes. There are CNIs, and you have to go through network policies rather than through hardware in your stack. No hardware can work in this way. And native and custom network policies are indeed very different, as you already understand. But in industry, people still make use of native ones because they are supported by all CNIs, all cloud service providers. In certain cases, native policies are understood, but not the custom ones in certain instances. And you can go from vanilla Kubernetes to KubeShift. When you use custom network policies, yes, you get extension, but you are kind of locked into a particular CNI. At that, since it's policy as code, it's very transparent to all kinds of departments. We are all living in the era of DevSecOps, so developers, security, and operations guys need to have a general big picture and not go into each other's way. Let me give you a specific case. An injected library. And this is a case from one of our clients. In dev, everything works. In test, everything works. And then it wouldn't work. And they debug, and it doesn't work. And then they ask the DevOps team and ROC team, nobody understands. Everything is same. Turns out that the security guys ticked denial of sending network packets. That's it. If you do it right, by way of declaration. It wouldn't. You would just diff the two files, and you would ask the security guys to change the network policy. They change the YAML file, and that's it. And you don't have to lose your resources and your time. Everything is declarative and clear. And this is where we're going to. Infrastructure as code, documentation as code, and all that, right? And policy as code, detection as code, everybody is going in this direction so that you can maximize transparency for all the departments that are in charge of security and reliability. And Kubernetes, since it's all built on YAML, it's convenient this way. And you can always go into your Git and understand the dependencies and who's isolated and not isolated. These are our references and useful links. Here you can find anything you need to know if you are just a beginner, how to approach it, how they evolutionize, how they change. There are additional viewers and all that. I think this would be enough for you, at least initially, to use it in your companies. That would be all. Thank you very much for your kind attention. Hopefully this was useful, and we'll be happy to take your questions.
Добрый день, я здесь. Спасибо. Видно меня? Да, спасибо за доклад, очень интересно. Скажите,
Thank you very much for your presentation. My question is this: could you please share with us your personal expertise? How expensive it is to use Calico plugins in case you have very detailed network interaction between the pods? What are the specs? What are the resources you would need in case you have this kind of load? And a follow-up question would be, you mentioned the opportunity of switching the pod to underlie a host network so that pod uses host interface as if it were a Kubernetes network. Have you had in your practice, and is it a good idea, to make use of underlay network and underlay solution like new generation firewalls, network policies, to manage traffic inside the cluster so that you don't have to describe it explicitly with Calico and other plugins? And sorry, I have a third question. What are the ways you have in mind to follow traffic inside your cluster, like net flow, everything, like telemetry, all kinds of flows? How do you think you could do it? Thank you. Thank you for these questions. Let me start from the top. Hardware specifications. Usually it goes together with Kubernetes. It's not done separately. Nobody allocates resources separately for Calico. It's a network. And since it's a network and it works with all packages, this is the most flexible variant. So you would have overhead if you go through a different network. Right. As far as underlay networks are concerned, usually host network true is not used for business microservices. If you have like a store, the business microservices like billing, payment, shop window, if host network true is used only for agents, monitoring, in infrastructure things, that is, but rarely. The idea of having next generation firewall is not good, I think. We'll have abstractions on the left and on the right. It would give you quite substantial overhead. And when you come to companies and they say, we have 10 gigabytes of traffic, how you go about it? If you have high load, you have enough of traffic, and if the traffic goes somewhere else, it creates huge overhead, and they hate it. So, like I mentioned in my presentation, we're all for declarative approach. You want to have everything clear, what goes on. And as far as visualization, what goes on, well, usually those are commercial solutions. Like I said, the IP wouldn't give you anything. Because you'll have one API talking to everything, and the other one. So now we want to understand the context, irrespective of whether it's a pod or a container, irrespective of namespace. Part of interface in Selim there is this Hubble tool, but it also has its own constraints. In Calico, they don't have a free of charge tool. Everything else that you have is commercial. In Lantry, we use eBPF. We look at who goes where and draw arrows. Service mesh. Some people work with service mesh. In Link RD, they have it, and they draw these flows. So they add a proxy on top of each microservice. Service mesh say that it's plus 500 megabytes per container. Not everybody is ready to use that. But it really depends on your infrastructure, obviously. Thank you. So you mentioned containers and you mentioned namespace. I'm interested to know whether you have additional requirements to Linux kernel. If it works in a container, would you have to have user namespace to have tuned up or syscontrols? Since user namespace increase attack surface, probably you should avoid it. Linux kernel have their own kernel namespace, and you had namespace. So you mean to say that there are kernel namespaces in Linux? This is done by CNIs. The container doesn't know about it. It doesn't have to have additional privileges. In bags, they take all privileges. There is this drop capabilities thing, and they take it away. And this is done for isolation purposes. For network policy, it's not needed. If there is a network plugin on IP tables, then every time you use a network policy, your IP tables once again. In eBPF, IP tables are not used. And it drops packages. And inside the container, do you need to introduce root, or it can go? No, not necessarily. If it's about CNI, in the latest Kubernetes versions, they are rootless. It goes from root. If it escapes the container, yes, it goes to the root. Yeah.
Спасибо за доклад. Здесь. Подскажите, пожалуйста, я слышал про вариант решения для...
I heard of a variant for heterogeneous environments where you have Kubernetes and a lot of other things. So you do it through BGP, and subnetworks with containers go outside. We haven't encountered anything like that. You can put it as network in another system, and you can then go from non-cube to cube and explain the interaction. We haven't encountered anything like that. But I think you should go to Alibaba and other providers to have anything of this kind. Thank you.
Добрый день, спасибо за доклад.
Thank you for this presentation. Look, Calico gives logs that are not very informative. Do you think we can send it somewhere else so that logs are taken and analyzed for additional information that cannot be seen with the naked eye? By default, no. Calico has Calico Enterprise. Time is out. Hi, I do have a question. How about is TCP? You can use TCP and ATP? Yes. The answer would be, but not no. It's a range, right? Yes.
Здравствуйте, краткий вопрос. Правильно я понимаю, что
Do I
есть
get it right that if you have this mode on, you mean host network through? Yes, that then you can use NGFW, right, to containers. Yes, but it goes not through virtual interface, through host interface. Yeah.
И айпишник у него будет уже нода конкретно. Используя под сети, а из хостовой группы будет такой же айпишник, как у той ноде, где он запущен.
такое уже практикуется или
Do you practice it?
Не советуется это использовать для безопасности против и часто на тех же вот себе упоминал policy engine, типа Kubernetes, окей, Epic, там есть отдельные политики, чтобы не было просто network. Обычно это упрощает.
Sometimes it simplifies attacks and then the container escapes. So we recommend to use less of what you're asking about. Thank you. Sorry, time is up and it's time to pick your favorite question. What would be your favorite question?
Мне кажется, 3 первых вопроса. Я мучился, запоминал.
Okay, great. Thank you. Thank you very much. Thank you for your presentation.